In this video, I show you how you can apply the dimensional design approach to the NorthWind case. At the end of this video, you should be able to apply the 4-step model, draw the Kimball bus matrix, and draw a star schema and ER model in ASTA. Let's first recap the 4-step dimensional design approach. First, you choose the business process. That could be anything from the sales process, raw materials purchasing, payroll, customer orders, shipping to warehouses, or manufacturing. Then you go to the next step, which is to declare the grain. The grain is what constitutes a row in the fact table. It's important to choose that as atomic as possible because you can always roll up from a lower level of details, but if you do not capture it at the lowest level of detail, there's no possibility for you to drill down in the data later. Then you move on to identifying the dimensions. The dimensions is the context for the data, and it's important here to remember that the context, so the relationships to each of the dimensions, uniquely identifies a row in the fact table. Then once you have done that, you move on to the 4th step, which is to identify the facts. This is the metrics. So it's the quantitative representations of data. It could be quantity, it could be amount, it could be discounts. If we look at the case description for NorthWind, we can see that Andrew is requesting that you model the sales process. He also mentions areas of finance, logistics, and marketing. So you're kindly asked to conform your dimensions for the business, so to cover all areas. If we consider the sale, we have to ask ourselves, what is the grain? What represents a sale here? And as you remember from the Bilka case, then we have both orders and line tables. So here the most granular representation of a sale would be any line item in a sale. So if a customer purchases 2 blue goods and 2 red goods, then the line item saying how many of each respective blue or red good have they purchased. Then we need to look at what dimensions is Andrew requesting, and if we dig further down into the details of the case, Andrew mentions that in NorthWind, sales are commissioned by sales representatives to customers. So we will have both here something with a sales representative, which could generalize to employee, and something with a customer. Then we also know that each of these sales will have a product and a shipper on. If we move further down, we also see mention of something with accounts receivables, but this doesn't connect to the sales process. And likewise, if we move further down, there's mentions of payroll and marketing. This doesn't relate to the sales process. So we need to understand, based on the description that we get and our domain knowledge or our insights into the business that we generate while working on the data warehouse, what connects to the business process and what connects to the sales process and what connects to other business processes in this company. When reading the case, we also need to pay special attention to the different attributes that will end up in our dimension tables. So for example, Andrew is talking about dairy being an important category. So category needs to be an attribute on the product dimension. We also need to watch out whenever we hear something about shippers that needs to also go into the product dimension, because we need to be able to sort on that. We also need to pay attention to when he says something about delivery times for discontinued orders. So delivery time, is that something relating to sales? Is it something relating to logistics? Is it both? Can it be on the same dimension? We need to pay special attention to this, because we need to know which attributes are going to be on the different dimensions, as you will see in just a minute when we move on to actually drawing the star schema. As you can see on my slide, I also mentioned time in a parenthesis, and that is correct because Andrew says that, of course, things change over time, and it's mandatory that we can see how these metrics change over time. But we will get back to that and dealing with date and time in a Kimball data warehouse separately later. So for now, you can just ignore it. Then in the fourth step, we need to be able to define the metrics. And if we look into the text, we will see that that Andrew mentions quantity and amount. So that needs to go in there, definitely. Based on the case, we can also make this rough draft of the Kimball bus matrix. So we will notice that Andrew says that everything needs to be tracked by time. So that is why you can see that the dimension date is applicable to all the different business processes. If we look at accounts, that's something related to finance. So that will not apply to, for example, the sales process, but it's an important dimension to be able to sort on when we're looking at financial transactions. Then if we look at product, it's the one that's shared amongst many of the different business processes. However, it's exempt from payroll because payroll relates to how we pay our employees, and that's not related to product at all. Then if we look at the employee dimension, that is, in this case, it is assumed to be shared between sales and payroll. However, employees is not related to, for example, inventory management. And from the case, we also don't see that it should be related to marketing. So that's why there's not an X here. Again, we have the customer dimension, which is important for the outgoing part of logistics. It could also be important to marketing if we have marketing efforts tailored to specific customers, and it's definitely related to sales, and it's also related to the billing processes in finance. Then we have shipper, and that should also be related to sales and incoming and outgoing in logistics. As you can see, the rows in this table relating to business processes are not identical to a organizational chart, but actually represent business processes that generate data. And that is an important thing to remember in Kimball's dimensional design, is that we should try and build this bus matrix so that it aligns with the business processes and not with the final reports. And the reason that we want this is because we want the data warehouse to live on with the business and not die with the reports that are currently being ordered. We want it to remain flexible so that it can support business analytics needs of the future. And if we design it too narrowly on departmental aspects or report-centric, then we won't have this flexible data warehouse for the future. At the same time, a part of the reason for why we want to build this data warehouse is to have a central repository on data so that regardless of where and what side of business you're looking at the data from, it shows you the same. So if, for example, we were to make separate product dimensions for sales, for billing and finance, for logistics incoming and outgoing, and for logistics inventory management, and for marketing, then what happens when these product dimensions eventually move away from one another, so that one dimension includes all products, but another dimension only includes a subset of it? Then we will, when we look at the finance aspects of our data warehouse, see that the entries are spread over multiple products, whereas in the sales, all of a sudden, maybe discontinued products have been taken out and we can no longer see them here. Then we don't share the same version of the truth. Let me try and paint a picture for you. This is a picture of an elephant, and it's a metaphor for our data warehouse. And what happens if we do not conform dimensions is that one person is going to look at part of the data warehouse and say, it's a giant cobra. Whereas another one looking at another part of the data is going to say, no, it's a big, giant gray wall. And maybe a third person is going to look at it and say, no, it's a mouse. It's actually a mouse. So then if you build the data warehouse and you do not conform the dimensions and you don't provide the business with a conform view on data, then when they want to use that data warehouse to improve business decisions and take informed decisions on their data, they're going to think that the reality is actually different because they don't share the same view on the same centralized data. In this next part of the video, I'm going to show you how to draw the star schema in ASTA. ASTA supports two types of notations for ER diagram. The first one is Integration Definition for Information Modeling, or IDEF1X, and the other one is IE, or Information Engineering. Once you have drawn the ER diagram, ASTA gives you the possibility to convert this into a UML diagram.